Welcome to the first part of the Omega Red Group webcast on BS EN 62305 2006 Protection Against Lightning. This is the first section of the webcast and includes an introduction and covers part 1 of the standard dealing with general principles. For your convenience, we have split the whole presentation into 5 short sessions so as you can dip in and out when you have a spare 10 minutes. I'm Mike Henshaw, a qualified electrical engineer with 30 years experience of contracting in the electrical and lightning protection sectors. I have been a member of our trade association's Lightning Protection Committee for many years, and in order to provide appropriate installer representation, I served on the British Standards Institute Lightning Protection Committee GEL 81 until recently. I wrote the UK guidebook on the 62305 standard on behalf of the British Standards Institute, and that guide, reference BIP 2118, has been reviewed and has the full endorsement of both the BSI and Atlas Lightning Protection Committees. The guide is published by the British Standards Institute and is available directly from them. We recommend incorporating the guide within any specification you publish for a lightning protection requirement, as it brings practical logic to what is otherwise a very academic standard. I will be co-presenting this webcast in conjunction with my colleague, Andy Milinsky. He also has 30 years experience of contracting in the electrical and lightning protection sectors. Andy has replaced me on GEL 81 and has begun attending meetings of the CENELEC and IEC Lightning Protection Committees responsible for the production of the new standard and its first amendments, due to be published in 2010. With some issues still to be resolved at international and European level, a thorough understanding will only come following further clarification and once the industry has experienced in practice the many new concepts within the standard. The purpose of this series of webcasts is to highlight the structure of the standard and address the many issues that are different to the old standard, BS 6651, and identify the solutions agreed with the Atlas and BSI Lightning Protection Committees. This should help ensure that your potential exposures and liabilities are identified and for you to know what the standard expects of our specialist industry sector. We have provided a section on our website www.omegaredgroup.com in order to allow you to post any questions you may have. As we expect there to be many and varied questions arising from this webcast and answering them individually may prove difficult, we have provided a section on the site where we will post answers. The old standard is now more than 20 years old, and our understanding of lightning and how to deal with it has grown greatly in that time. So the IEC has been working on a new international standard for over 10 years. Once this new IEC standard 62305 document was complete, it was adopted by CENELEC as a European standard. Under European law, the UK will withdraw its own national standard BS 6651 on the 30th of August 2008 in favour of the BSEN standard, which will then be used for all new projects. The new 62305 standard is in 4 parts. Part 1, General Principles, Part 2, Risk Management, Part 3, Physical Damage to Structures and Life Hazard, and Part 4, Electrical and Electronic Systems within Structures. These parts will each be covered within the next sections of this webcast. Presenting us with probably the most radical changes within any existing standard seen in this country, the new standard is very academic in its approach. We consider this radical change as a double-edged sword. It creates a completely new operating environment. There is a need for significant upskilling of less able practitioners. The technical requirements and levels of understanding needed for properly engineered solutions are far greater than ever before. Nevertheless, for those organisations looking to provide a top quality service, it offers great opportunities to prove our commitment and competence. You will all be aware of the need to reasonably cover your potential liabilities under the new standard. To prove our industry's competence, Atlas has organised comprehensive 4-day training sessions for members who wish to improve their understanding of the new standard. These training sessions will be complemented by an accreditation that will confirm the competence of UK practitioners under the new standard. At Omega, we have gone a step further and have provided our designers with between 10 and 15 days each of further training on the application of the new standard. All our designers will sit the Atlas accreditation so that we can verify our competence and demonstrate that we have taken your needs seriously. We consider it vital that whoever you use to deliver your lightning protection requirements should have proven competence to meet your needs by reference to their Atlas accreditation. Atlas is presently the only body in the UK with the knowledge and application to ensure that its members are competent to apply the requirements of the new standard.
The first part of the standard does as its name suggests. It identifies the general principles underpinning the other parts of the standard, and so it is unlikely to be used by contractors on a regular basis. The standard recognises that there are also sources of damage that influence the risks associated with lightning, in addition to those associated with the structure to be protected. The service lines entering the structure and the structures at the other end of those service lines now add to the risk. They can all be struck, and consequently they could transmit lightning current towards the structure to be protected. There are now 4 different lightning protection levels. These are derived from the lightning first short stroke peak current, which is now attributed with a wave shape of 10^350 microseconds. Earlier British standards used a wave shape of 820 microseconds. As you will be aware, the energy under the new wave shape is significantly greater than the old shape, and this has implications for the design of surge protection units. You will note that the maximum peak current associated with the classes are 200,000 amps, 150,000 amps, and 100,000 amps for lightning protection levels 1, 2, and 3/4 respectively. These levels are determined by a risk assessment, which we will cover in the next section. The standard also now defines different lightning protection zones. Each has implications for the type and location of protection offered to the structure. The items of plant on the structure and the type of location of bonding offered by physical connection or surge protection units. In this example, LPZ0A is an area outside the structure and outside any zone of protection, and as such is exposed to the full lightning current by virtue of being struck, and will also be influenced by the full electromagnetic field. LPZ0B is an area that falls outside the structure but within a zone of protection. This zone will not be exposed to the direct lightning current by virtue of falling within a zone of protection, but will still be influenced by the full electromagnetic field surrounding the strike. LPZ1 is the zone immediately within the structure, and this zone will not see the full lightning current, and the influence of the electromagnetic field may be attenuated by the influence of any metal part within the fabric of the structure. Finally, LPZ2 will fall within the influence of the further attenuated electromagnetic field. These ever-increasing zones of protection coordinate with any system of comprehensive surge protection used to protect the electrical and electronic systems within the structure. We will cover requirements for the protection in these areas in detail later. There are many other parameters to take into account that we can't cover within the constraints of this webcast. It is worth mentioning, though, that the test values associated with lightning protection system components will have been satisfied if the equipment used on the lightning protection system complies with BS EN 50164 series. They ensure that the performance characteristics of the equipment are adequate, and this should assist with the longevity of the installation. That ends the first in the series of webcasts on BS EN 62305. In our second webcast, we will cover BS EN 62305 2006, Part 2, Risk Management.